What did the post lady bring today? Yes, it is a lady. The mail comes in a community mailbox down at the end of the street, and one day I was going there to check the mail, and the lady was there with the whole faceplate open on the mailbox so that she could put everyone's mail in all at once. And I said I was here for this mailbox, and she said, "Oh, I'm the one who puts all these packages in bundles for you every day." So now I know who handles the mail. So what did she bring? She brought a power adapter. I don't know what this could be yet, because could be anything. Oh, see, that's not a power adapter. That's a gender changer 9-pin DB. So I got two of these, 9-pin female to female. So if you want to have two cables or whatever, just the end of a device that happens to have male pins, and you only have a male cable available, you're going male to male, well, you stick the female there, and you have a female there. Connection made. You don't have to order a brand new cable with the proper polarity pins on it. I already have a female to female DB9, but look at that. That's old school clunky. Let's streamline it up a bit, shall we? Serial DB9 female to female gender changer, 99 cents from wonderful buying, 365.88. Rather straightforward. Female on each side. Ultimately, it converts a DB9 male to a DB9 female. So if you've got a male connector with pins, you plug it in here, and you've got a female on the other side. So you've converted a male cable or connector into a female cable or connector. Hopefully, though, these little nasty terminals don't get in your way like they did on my modem experiments. I don't know if I can undo these if I need to. We'll see. But 99 cents to have around. I'm sure it'll come in handy. Plastic sheet. Well, you know, I did order something that could be considered an actual plastic sheet, but I don't think this is it. This is chips. So what kind of chips did I order? I've ordered a lot over several months, so I don't know if these were recent or in the past ordered. They could be simple digital logic chips, or they could be specific things like DTMF decoders. Well, this one's a 4021. 10 pieces of this 4021 shift register, $2.85 from Horizon Electronic. And they didn't really give any more of a description. I guess you know what you're buying. 8-stage shift register with a wide operating voltage range. So this, I believe this is the same shift register used inside the original NES Nintendo gamepad to read in the 8 buttons, up, down, left, right, B, A, select, start. It reads in those 8 inputs and shifts them out serially into the NES. The NES generates a clock, and it reads all this from the controller. So all the buttons would be connected up here. The NES would generate a clock, and it would control whatever it needs to, provide power and ground, and it would read in the serial, all on that 7-pin controller connector. And that's how they can get all those buttons with only a few pins. Shift registers are useful for a lot of things anyway, but maybe one day I'll try to build some sort of NES controller circuit. So it's just a part to add to the collection of general purpose things that it'll be there when you need it. Expansion board module. I always look forward to expansion board modules. They could be voltage regulators, they could be fancy interfaces like a wireless module. And this one is, it looks like some sort of USB. I think I see an FTDI logo, so this might just be a USB transceiver to TTL UART. So there's all the familiar serial port looking signals: CTS, DTR, RTS, transmit, receive. So this looks like a USB to UART transceiver. FTDI 232 to USB TTL 3.35 volt serial adapter, $1.97 from World Chips. Well, this is rather straightforward. There's no real need to go and look up the FTDI datasheet. Basically, what you do, you plug this into USB, and the FTDI chip, if you have the correct FTDI drivers on the system you've plugged into, it'll register as a COM port, and you'll have access to a TTL version of all those serial pins: transmit, receive, clear to send, request to send, etc. So let's say you have an Arduino with 5 volt or 3.3 volt data coming out on a UART. You have a transmit and a receive UART on your Arduino, and you want to log that data in a PC text file or something. You plug this in, you connect transmit and receive of the UART appropriately on here, open up a terminal program on the computer and tell it to connect to this whatever COM port has shown up, and suddenly you can communicate with the UART and whatever Arduino. You can send data both directions or whatever you want to do. It's basically a serial port for a computer that will let you hook up to your hardware and communicate. Bulb transistor. I'm not too sure what that means, so this is going to be a mystery pack. So these look like crystals for oscillators rather than bulb transistors. Hey, I see different stuff. There's like it looks like a watch crystal with the 2 radial leads, and then there's different other crystals. What is that, an HC49 package? I'm not sure. I think this is a multi-pack. Crystal oscillator assortment, 15 values between 4 and 48 megahertz. For what though? Because there's a 32.768 kilohertz watch crystal in here. So they are through hole, 15 of them for 99 cents from Module Fans. So these are supposedly common used crystals. You get a total of 15. And yeah, I guess they start at 4 megahertz and go up to 48 megahertz, but there's this 32.768 kilohertz. And it says 3 by 8. Is that 3 millimeter diameter by 8 millimeter tall package? Which is different than the rest of these. So I thought, hey, stock up parts, get a little assortment kit. Why not? $1. Now, this is a kind of small, lightweight package, and it says electrical equipment and supplies ×2. Well, I hope there's an oscilloscope and a function generator in here. Okay. A bunch of chips ×2. 8-pin dip. All right. Are these different? So, X9C103P. You know what? That sounds like a digital pot 10K. I remember ordering this recently, and this is related to the 555 tone generator as well. I was thinking, if I can have a digital potentiometer that I can control the resistance from maybe an Arduino, I could maybe use these digital pots to sweep the range on a filter on the audio, or sweep the frequency of the audio up and down, and create some fancy effects. So this is going to be used in tone generators and sound effect generators. 5 pieces of X9C103 non-volatile digital pot, $2.85 from TRS Seller 2012. They don't have much to say about it other than it's brand new and high quality, so let's look it up. This has a resistor array, wiper switches, and a control section, and non-volatile memory. The wiper position is controlled by a 3-wire interface. You get 100 positions on the wiper of the pot, and if you store your current position in non-volatile memory, it'll be there when you power up again. The overall resistance tolerance end to end, I guess if you're using all 99 resistors, well, there's going to be a tolerance stack up with having a whole bunch of resistors, so overall they guarantee plus or minus 20% tolerance. It's available as a 1K, 10K like I got, 50K, and 100K. So the way this basically works You give it power and ground, and there's a chip select in case you want to have multiple potentiometers on this same control network. So you set 1 bit for whether you want to increment up or down in resistance, and then you just kind of clock it with an increment, and it'll either go the next step up or the next step down, and it will switch in whatever kind of resistors you need in your entire selection. So just like a regular potentiometer, you have one end of a big resistor as one terminal, the other end of the chain of resistors as the other terminal, and the wiper is going to be represented by FETs being turned on and bringing your common terminal into the circuit somewhere along the path. Engineering ruler. Now I don't remember buying that, and I'm not sure if it feels like a ruler. Let's see. Well, to me, this looks like it should have been called expansion board module. Let's see what we got. Can't open. Well, this is an interesting looking module. It's got 2 sets of headers, a single row and a dual row. I don't recognize offhand what this is, so we have MCP23017. It looks like serial clock and data I2C, but it also looks like SPI interface. Maybe this can work in 2 modes. So yeah, this is intriguing. I don't know what it is. Let's go find out. This part with this MCP23017 I didn't recognize is a bidirectional 16-bit I/O expander. It's got I2C serial interface. $1.65 from Alice 110 1983. So in the specs here we have 16 bits bidirectional, as we already know. The default for the I/O pins are inputs, so of course that's the safe way to do it. If you're in a circuit and these pins are hooked up to something else that's driving a high or a low push-pull, so you basically have a direct short to ground or VCC, you don't want this to power up as an output and also be trying to drive the opposite. So you get 3.3 volts being driven somewhere else onto this bus, and this is trying to ground it, and now you've got a power short. So the safe way, they power it up as inputs, and then you configure it after you've powered up. So you can do a high-speed I2C interface up to 1.7 megahertz, or high-speed SPI interface 10 megahertz maximum. You have address pins, so you can have 8 addressable devices on the bus. Configurable interrupt outputs, configurable as active high, active low, or open drain. Whole bunch of other features. Low standby current, 1 microamp, and it looks like you can operate up to 5 volts. You can operate from 1.8 to 5.5 volts, standard operating temperatures, and with all these configurable interrupts and configurable output modes, it just sounded to me like a very good thing to have on hand if you can get it for low cost. And if you run out of I/O pins on an Arduino, if you've got an extra I2C or SPI interface, you can get 16 I/Os out of this. So as an example of trying to make sure this GPIO expander's digital inputs and outputs are going to be properly recognized with other logic families connecting up, if we just, for example, look at the input low voltage, this is minimum and maximum. So when some other device is driving a low signal into this GPIO input, in order to be recognized as a low, VSS, which is ground, will be the minimum voltage that will count as a logic low to be recognized, and the maximum input level that this chip will accept as a logic low is 0.15, well, for the GPIO, 0.2 times the power supply VDD. So if we have a 3.3 volt power supply, 0.2 times 3.3 volts is 0.66 volts. So what this means is if there's an input on this GPIO expander and its voltage is between 0 and 0.66 volts, this chip is going to count that as a logic 0 input. So likewise, for an input high logic signal, for GPIO, this chip will, of course, accept VDD, 3.3 volts in this example, as a valid high, and it will accept any other input voltage down to 0.8 times VDD. 3.3 times 0.8 is 2.64 volts. So anything between 2.64 and 3.3 volts is going to be considered a logic high being received on this GPIO expander input. And you would do the same on the outputs. Whatever this GPIO expander is giving out, high or low outputs, you would figure out what voltages it's going to present to some other device, and you would have to go to that device's datasheet and make sure its inputs are going to be accepting your voltages as valid high and low. If we go over to any other datasheet, here we have a 74 LVT 08 3.3 volt quad 2 input AND gate. Okay, so we're going to consider that this AND gate is driving our GPIO inputs on our expander. Are the highs and lows generated by this guaranteed to be seen as high and low on our chip? So maybe this wasn't the best logic chip to choose as an example, or maybe I should have chosen 2.7 as my power supply instead of 3.3 for the GPIO expander, because this datasheet is talking about whatever it wants. If we're talking about this AND gate giving out a logic high, and we want to read this in as a guaranteed logic high on our GPIO expander input, this is valid up to 3.6 volts, this rule, so we got 3.3. So V output for logic high from this AND gate, if VCC is 3.3, the lowest it's going to generate for a high output is VCC minus 0.2. So 3.3 minus 0.2 is 3.1. And we said our GPIO expander will accept anything between 2.64 and 3.3 as a logic high. So this would work. So that's how we would go about making sure this will properly integrate in whatever system we're going to try and use it to expand the GPIO on. Plastic sheet, and 1x modules. Try not to cut it. Now, like I said, I ordered some stuff that could be called plastic sheet, and this is puffier. If I could get into it, I'm afraid to cut it. Oh, can't get it. Ah! Yeah. So what is this? Finally, the Lego breadboard base plates. Plastic sheet. Ha! Not what I expected, but hey, pretty good description. And 3 things. Okay, let's start with the funnest. Where's my Lego boards? So a bunch of breadboards with little Lego kind of looking mounting studs on them. Some are hard to see. So the way this works is the studs on the breadboard go in between the studs on the base plate. And you can keep all of your tiny circuits under control. 99 cents, DIY electronic. The only specs they give are the overall board dimensions and how many tie points are on those breadboards. Now this is a USB tester. It looks like, based on this, voltage 3 to 9, current 0 to 3 amp. Is this one of those meters that you can plug into USB and then plug something in and it will tell you how much power you're using? It looks like I can plug this into USB and then I can plug 2 USB loads in and it will tell me voltage and current. I'm not really set up right now to be able to plug this into anything. I'd probably need a USB extension cable so I can bring a USB port to here on the bench. So I'm going to put this on the to be tested list. I think what I'm going to start doing is more of a mailbag follow-up or a status of projects kind of thing. So we'll lay this aside and work with it later. USB charger doctor, voltage charging detector amp, whatever. I think maybe, is this meant to be used so that if you're using a USB plug as a charging device for a phone, this will tell you how much current you're using? I don't know why they're relating it to charging detector. I just want it in general, whatever I plug in, I want to know how it's being used. But $2.33 from DIY Electronic. I believe mine is the KW201, so, well, it'll measure a voltage 3.5 to 7 and a current up to 3 amps. So that should be well within the range of what we're going to be needing for a USB port monitor. What else did I get? These look both identical, so I will look at one, lay one aside. As usual, I don't recognize this at a glance, and so I have no idea what it is. And this one doesn't want to come out. The pins are sticking through this anti-static bag, and it's locked in. I can't even cut it free. What's going on? All right, we're going to use this hobby knife to actually sculpt an opening here. I'm doing surgery. There we go. Perfect delivery. An Opto Isolator. It looks like we have 4 channels, and it uses this device. It's kind of hard to read this. TLP281-4 for 4 channels, I assume. So let's go check out the specs. Now, I wonder if I got 2 of these, so I would have 8 bits if I needed to do an entire port isolation or something. 4-channel Optocoupler, $1.14 from DIY Electronic. I wonder if it's easier to look up the datasheet on this to see, but this is probably copied from there anyway. So, as is common for an Opto Isolator, we probably want to hook up something digital that we want to isolate from something higher voltage or noisy external system. And yeah, this is just a general blurb on why would you want to use an optocoupler for anything, so let's try the datasheet. Alright, so the TLP281-4, 4-channel, collector emitter voltage 80 volts, that's the kind of stuff we need to know. And, well, yeah, it's an optocoupler, opto isolator, so you power your LED here and you have a transistor that can do 80 volts across collector emitter, and you do what you need to do on your other side and keep your digital stuff digital and clean. And if you need to switch things off and on quickly, then you'd probably want to check the timing characteristics. So it looks like you got up to 3 microseconds to get this thing to turn on and turn off. So if you're trying to isolate an actual data signal or a clock or something like that, you would have to look at this sort of timing and make sure this is going to switch on and off fast enough for the data that you're sending through it. But if you're just trying to turn a relay off and on, it's just going to be irrelevant. So I just got it for general purpose playing around. You know, if I want to just isolate something for some reason. For example, if I'm interfacing with, if I get into using an old PC like a 386 or a 486, if I want to build some sort of Arduino circuit, I'm probably going to do something like Opto Isolate, just so both ways I don't blow up the Arduino or I don't blow up the PC by having weird connection issues and one impacts the other in an unexpected way. I want to keep them in their own world, and if one goes weird, it won't hopefully impact the other. Quantity 1 diode. Yeah, I kind of think there's more than one in here, so maybe it's one kit of assortment, of diode assortment. Oh, it's LEDs. They are all a white diffused case, so I have no idea. They have 2 pins. You know, recently I ordered bidirectional, like bicolor, maybe red and green in the same package. So based on polarity on the pins, it will be red one way, green another. And I used to have one. I know I bought it at Radio Shack, so it was probably 1 in a package for $2.99. And I liked it because being diffused compared to a clear case, I have other clear case ones that have red in one direction and green in the other. You can see the individual LED chip in there, and it's not even that bright, and maybe you have to look at it straight on instead of from the side. So I liked these diffuse ones that I used to have, But the thing about them is you can do red in one direction, flip it around and get green, but if you put AC, it gave a perfect yellow. So I just thought I'd order some of these and see if they would do that. But I don't even know if that's what these are. Let's just get the old LED tester out. Red in one direction, flip it around, green. So yeah, you can't see on the camera very well the way I can, but yeah, that being diffused and being red-green, that's perfect. That's what I wanted. And so I will have to try putting AC on later and see if I get yellow. But yeah, that is exactly what I wanted. So quantity 100, 5mm, bicolor, red-green, diffused LEDs, 2 pins. So there's no common anode or cathode like a third pin. You just have to either put this in one direction or flip it around in the other direction and it'll light up the red or the green. Or hopefully if I put AC, it'll light both up and give me yellow, mixing colors. The diffused casing will help hopefully give me yellow, to be tested. For the 100, it's $3.50 from Shengming Electronics. Forward current 20 milliamps, forward voltage between 1.8 2.2. That's pretty standard sounding. And really nothing else to say. This final one for today is called Needles Back. Makes no sense. But this is a classic. Obviously, early this year, end of January, I bought this. So I have no idea what needles back means. One way to find out. Move, LEDs. Oh, now I know what that is. These are pin extractor tools of all kinds, all chained together here. So, you know, when you have a connector that has a pin with a wire crimp on it and you stick that into the plastic housing of the connector and it's got little tabs that snap into the housing and hold it in. Sometimes if you need to remove those and you try to jam a screwdriver in and force the pin in and yank it out of the connector housing, you might break it. So these are meant to do different kinds of connectors. So you just slip this in the housing and it nicely puts all of those retention tabs inward so that you can just nicely pull it back out of the housing. So here's a computer hard drive power cable as an example of what I'm talking about. You have your plastic housing and you have your crimped wire pins. So right there you have these tabs that splay out on each side. This one may be a little bit bent, but there's one on each side. So when you insert this into the housing, these will go inward as they're going through, and then when they reach out, it's like a butterfly pin. It'll come back out and you can't pull it out. So if you install this pin into the connector, there it clicked into place, and now it's retained. I can't get this out. So what if I want to get this out? Well, I could try to look down in here and see that there's tabs, and I can poke a screwdriver and break it and try to pull this thing out. And I got to try and get 2 pins at the same time with a screwdriver or really thin pliers. By trial and error, it's a simple hollow tube. You just put this over the pin. It goes all the way down. It fits nicely. It doesn't feel like it's being aggressive. It just goes right on and it pushes in those hooks, and then away goes the tool. It's not needed anymore. And you've removed this and you haven't really damaged it, and as I showed, you can reinsert it and it'll do its job again. I haven't broken it. So the right tool for the right job when you need it makes life less annoying. All right, the terminal remover tool. Car electrical wiring crimp connector pin extractor. This whole kit with all of these on it, $3.66 from King Zone 88. I believe when I was looking for these, I think the prices were all similar, at least at the time, so it might seem a little bit expensive, but When you do need the tool, it just does its job really seamlessly, and it's worth it to have it around if you need it. So here's an example of the kinds of terminals that each one is meant for. So this tool will slide deep into here and push these retainer tabs in, and then you can pull this back from this plastic retaining notch. Similar thing here, you just slip that in on both sides, it'll push in the things, and you can pull the connector back out and fix it up or whatever, replace it. And here's the specs on what you get. So later, if I actually need to see, do I have the right tool for something that I know the connector specs, I can double check this list and find out what I have. Now this is ominous. King Zone 88 is having a hell of a party, it looks like. And it's hot. 11 terminal remover kit. So I guess there's 11 of these key things on a key ring. They make a note here, don't pry the terminals with this kit, just push it in and pull the terminals out. So yeah, I guess what they're trying to say is maybe you'll break the terminals if you try wiggling this tool around to help jam it out. Or maybe these have a kind of cheap material on these keys, and you might break the key if you try to be too rough. You just push it in and it'll do its job, or else it's the wrong tool. Don't force it. And there you have it.